All right. When it comes to finding indefinite integrals of powers of trig functions, there's a powerful tool called a reduction formula. These exist for all 6 of the trig functions. We're going to take a look at how we use integration by parts to develop one of those formulas. From a standpoint of working on things in my class, you will be given a page of reduction formulas. You will not have to have these memorized or develop them, but some people might have an interest in how it works. Okay, so the process is going to look like this. We're going to separate this indefinite integral cosine to the nth power of x dx, and we're going to choose a u and a dv, and we're going to let the dv be a cosine x dx, and we're going to let the u then is going to be cosine to the n minus 1 x. So we're going to take one of those cosines away over here because we can do an antiderivative of that and say this must be a sine x then, and our du, taking the derivative of this, I'll probably need a little bit more space than I left myself there. So the du, this is a chain rule that has to happen here. The n minus 1 is going to come down. That's now going to be a cosine n minus 2 of x. And the chain rule is going to kick out a derivative of cosine x, which is a negative sine x. So kind of jammed that into that space. Let me move that over a little bit. And so we can say that the indefinite integral of cosine to the nth x dx is equal to u times v. So that's we'll start with cosine. Cosine to the n minus 1 of x times the sine of x minus the definite integral. And this, because of the negative right here, is actually going to make that a plus. And we can kick the constant, the n minus 1, out in front. And we would have a cosine to the n minus 2 x, and sine x times sine x is a sine squared x dx. And this is where we're going to then employ our Pythagorean identity that says that sine squared x plus cosine squared x is equal to 1, and so sine squared x is the same thing as 1 minus cosine squared x, and we're going to substitute that right there. So this is now rewriting again. Cosine to the nth x dx is equal to cosine to the n minus 1 x times sine x plus n minus 1 times the indefinite integral of cosine to the n minus 2x times 1 minus cosine squared x dx. We will split this piece into 2 different integrals, one that looks like n plus 1 times the antiderivative of cosine to the n minus 2x dx, and then we've got a minus n minus 1 times the indefinite integral of cosine now to the nth, the n minus 2 times the second power, so this is cosine to the nth of x dx. That, again, is cosine to the nth x dx, cosine to the n minus 1x times sine x plus that. And so now I see this piece over here, and I can add n minus 1 definite or indefinite integrals of cosine to the nth x dx to both sides. And we will get that n minus 1 plus 1, that gives us a total of n antiderivatives of cosine to the nth x dx is equal to cosine to the n minus first x times sine x plus n plus 1 antiderivatives of cosine to the n minus 2x dx. And then all that's left then is to divide by, I'm not sure how my n minus 1 here became an n plus 1. We should probably change that back to an n minus 1. That is this same piece. Well done if you saw that and were screaming at the screen earlier, saying, why did you change that? All right, and all that's left to do then is divide everything by n. If we divide everything by n, we're going to get cosine to the nth x dx is equal to 1 over n times cosine to the n minus 1x times sine x plus n minus 1 over n antiderivatives of cosine to the n minus 2x dx. Okay. It's called a reduction formula because it took a problem that was about cosine to the nth x and reduced it to a problem that was about cosine to the n minus 2 of x. So this is an example of the reduction formula for cosine to the nth. Let's go ahead and do a problem. We'll keep it fairly simple here. Let's go cosine to the, well, we've got time. We'll do cosine to the 6th x dx. And so employing this formula, it would say that this is equal to, if n is 6, then this is 1/6 times cosine to the 5th x sine x plus 6 minus 1, that's 5/6 antiderivative of cosine to the n minus 2. N again was 6, so this is cosine to the 4th x dx. Now, the trick becomes in keeping track of what I have done so far. And I'm going to now use the reduction formula again just on this part, keeping in mind that it is 5/6 times that. So if I do the reduction formula on this part, the n is now 4. This becomes a 1/4 cosine cubed x times sine x plus 3/4 antiderivative of cosine squared x dx. So rewriting what I have now to this point, I have, and I don't need to keep writing, I know that this is what I'm trying to find. So I have a 1/6 cosine to the 5th x sine x plus 5/6 that I'm going to distribute through this. So 5/6 times 1/4 is 5/24 cosine cubed x sine x plus 5/6 times 3/4 is 15/24 times the indefinite integral of cosine squared x dx. And I can use my reduction formula for this part as well. Okay, so just that part is going to be 1/2 cosine x sine x plus, again, 1/2 times the antiderivative of cosine to the 0. So this is just going to be a dx right there. So the 15/24 is going to distribute through that. This, of course, antiderivative of dx is just x. And we'll throw the plus constant on there. So my final answer for the antiderivative of cosine to the 6th x is 1/6 cosine to the 5th x sine x plus 5/24 cosine cubed x sine x. Move this a little bit lower so I don't run into what I'm doing over there. Plus 15/24 times 1/2 is 15/48 cosine x sine x plus 15/48 x plus a constant. And that is the antiderivative of cosine of 6x, making use of one of the reduction formulas.